Today we're going to talk about how to write the equation of a line that is parallel to a given line. Here it is an example of two lines that are parallel. Notice these lines have the same slope and different y-intercepts. Lines that have the same slope are parallel. If they're parallel, they will never intersect. And they also have different y-intercepts. If they had the same slope and the same y-intercept, let's see what will happen. See, the lines are going to be on top of each other. They would end up being the same line. So we say parallel lines have the same slope and different y-intercept. Let's go ahead and look at an example of how to write the equation of a line that's parallel. First we have y equals negative 3x plus 1. And I want to write the equation of a line that's parallel to this line, and it goes through the point negative 2, 1. So the first step is going to be to look at your given line. So the given line was y equals negative 3x plus 1. And what I want to do next is determine what the slope is of this given line. And I'll look here, the slope of the line from slope-intercept is the coefficient of x, so my slope would be negative 3. Once I determine this slope, and I know I want the line to be parallel for my new one, I know the slopes have to be the same. So this will tell me that my new slope, that we'll do in blue, will have to be negative 3. Now what I want to do is write the equation. I know the slope of my new line. I know the new line contains the point negative 2, 1. I have a slope, I have a point, so I can use point slope. Now if you wanted to use a different form, you could use slope-intercept to get to the equation, but we're going to start with point slope. That's the most obvious. So I have y minus y sub 1 equals m times x minus x sub 1. And what I'm going to do is I'm going to plug my values in, and my final answer I'm going to write in slope-intercept, and we're going to compare the two lines. So my x sub 1, y sub 1, that's going to come from this point here. Okay? My x sub 1 would be my negative 2. My y sub 1 is going to be this 1 right here. So this tells me my x sub 1 and my y sub 1. So let's go back down here and plug the values in. I've got y. My y sub 1 is 1, so minus 1 equals my slope, and my new slope was negative 3, times x minus, my x sub 1 is a minus 2. And notice I'm using parentheses, and that's something you should be using as well. Now what I do next is clean this up, make it look a little more attractive. So I have y minus y sub 1 equals a negative 3, and the minus minus becomes a plus. So it's x plus 2. So I have y minus 1 equals negative 3 times x plus 2. I want to solve this for y because typically what we'll do is graph this line. So it's much easier to graph and slope-intercept. So what we'll do next, before I add the 1 to both sides, I want to distribute the negative 3. So I have negative 3x. And negative 3 times 2 is negative 6. And I have y minus 1. Then the only thing left to do would be to add 1 to both sides. So y equals negative 3x. And if I add 1, I get negative 5 over here. And here's my answer. This line is going to be parallel to my original line. They have the same slope and different y-intercepts. Okay, let's look at one more example. I want to write the equation of a line that is parallel to 2x plus 3y equals 4 and goes to the point 6, negative 4. Now look over here. This is not in slope-intercept, so I can't say that 2 is my slope. What I have to do, since this is in standard form, is take my equation, and I'm going to have to do some manipulations. In order for me to find the slope, I'm going to have to solve it for y. If I solve it for y, then I can look at the coefficient of x as being my slope. So I'm going to start by moving the 2x to the other side, and I get 3y equals a minus 2x plus 4. Now remember, slope-intercept looks like this, the general form, which is y equals mx plus b. So that's why I'm going to put the x, the negative 2x, in front of the 4. That way it kind of matches my general form. So I'm going to subtract 2x from both sides. And now I've got this 3 right here. I need to solve this for y. So it's 3 times. So I need to figure out a way to get rid of the 3. So what I can do is I can multiply everything by 1/3. If I do that, that's going to clear out my coefficient. So if I multiply by the reciprocal here, it's going to help get rid of that coefficient or make it a 1. So I'm going to take this whole thing and multiply by 1/3. Now the other option would be divide everything by 3. That's the same effect. So 1/3 of 3 is 1, and I'm going to get y, which is what I'm solving for. I've got a negative 2 times 1/3. Remember, I multiply across the top and across the bottom, so it's a negative 2/3 x plus 4 times 1/3 would be 4/3. And this is the equation right here that I'm going to use to find my slope. Remember, in standard form, this is not necessarily your slope. The coefficient of x is not the slope in standard form. You have to change it to slope-intercept. So now I can look at it and see that my slope is negative 2/3. So that's my old slope. The line that's parallel will have the same slope as the old one. So my new slope, we'll go over here and say new slope, is going to be negative 2/3. Parallel lines have the same slope. So I have a slope and I have a point. So I can use point slope. So I've got y minus a minus 4 equals negative 2/3 times x minus 6. Okay, remember, this is your x1, this is your y1. And then I'm going to clean it up. I've got a minus minus, so it's a plus, so y plus 4 equals a negative 2/3 times x minus 6. And before I move the 4, I want to go ahead and distribute the negative 2/3, so I get a negative 2/3 x. Remember, I'm going to multiply across the top and across the bottom, so a minus 2 and a minus 6 is a plus 12, and then a 3 times 1 is 3, so 12 divided by 3 would be 4, so this is a plus 4. And I have the y plus 4 over here. And then I'm going to subtract 4 from both sides. So I get y would then equal a negative 2/3 x plus 0. Now there's no reason to write the plus 0, so I'm going to stop right here. So y equals a negative 2/3 x. So now I have my two equations, and let's compare them. Remember, this is not your slope up here. So here my slope was negative 2/3 x. I'm sorry, it's negative 2/3. Here my slope is negative 2/3. They have the same slope. Here the y-intercept is 4/3. Here the y-intercept is 0. So they have different y-intercepts. So this is the line that's parallel to 2x plus 3y equals 4. So we've gone over a couple of examples of how to write lines that are parallel. Go back over it, study it, and I will see you in class.